Hello and welcome, dear learners, once again to Mathlete Minds. As we continue our journey of Class 10 Mathematics, it's now time to take up the next topic, and that is an introduction to trigonometry. Now, what exactly is trigonometry? Trigonometry basically establishes, or it's a branch of math which establishes or defines the relationship between the measurement of the sides and angles of a triangle, and it's an extremely important part of mathematics. Now, initially over here, we need to understand trigonometric ratios, which are the fundamentals of this chapter, and we need to ingrain them thoroughly so that we do not have any profound difficulty in the later on applications of trigonometry. Now, what are these trigonometric ratios and all that? Before we go into the depth of that, let's get back to remember that all these ratios that we'll be talking about have been derived or have been defined on the basis of a right angle triangle. And we know that in a right angle triangle, one angle is 90 degree and the side opposite that is the hypotenuse, the longest side of the triangle. So this is the fundamental. But before we proceed on to define the ratios, etc., may I humbly request each one of you to kindly like, share, and subscribe the channel as much as possible. Moving on to trigonometric ratios. Now let's understand what are these trigonometric ratios over here. So here we have a right angle triangle with angle C as 90 degree. So here if we talk about the trigonometric ratios, the first one of course is called as sine theta. Now this is not the full word over here. The full word is SINE. This is the full word, but when we are using it in maths over here, generally it is taken as SIN sine theta. So sine of this angle is a ratio of perpendicular by hypotenuse. This is the angle theta that I'm talking about, and this is the perpendicular and this is the hypotenuse. So sine theta is equal to perpendicular by hypotenuse. Then we have cosine theta, the short form is cos theta, and that is the ratio of base by hypotenuse. Then we have tan theta, that is the full form is tangent, and the ratio is of perpendicular by base. So accordingly, the sides have to be taken into consideration. Then we have the reciprocals. Reciprocals of sine is cosecant theta, the short form is cosec theta, and that will become h upon p. The reciprocal of cos theta is secant theta and the short form is sec theta, and this becomes h upon b. The reciprocal of tan theta is cot theta and this becomes b upon p. So these are the fundamental ratios that we need to understand over here thoroughly. And another important thing that we must always remember is now in this right angle triangle, the value of sine theta does not change even if we draw perpendicular over here or at any other point over here. Because once we draw this perpendicular, this triangle ALM and the triangle ABC become similar triangles and the sides become proportional. So LM and BC, they are proportional. AM is proportional to AM by AC is equal to LM by BC is equal to AL by AB. So whether we draw the perpendicular here or the perpendicular here or at any other point away or increase the length of the hypotenuse, the value of sine theta will not change in this particular case. But that does not mean the value of sine theta will not change for other triangles. Definitely it will change. In this case where we are getting these two similar triangles over here, the value remains unchanged when we draw these perpendiculars at different distances over here. So that must be kept in mind. So that is the next important thing that you must know over here. And then these values p by h, p by h, p by b. To remember this, we have a small statement over here. Some people have curly black hair, curly brown hair. Some people have curly brown hair turned permanently black. Turned permanently black. So this is, if you remember this statement at least, initially the ratios will be very easy to remember. Because, see, if you have, this is sine, people have P upon H, cosine, this is curly, brown hair, B upon H, this is tan, turned, P upon B, permanently black. So remember the statement and these ratios will automatically be remembered. Moving on, Now let's see how these ratios affect our calculations, how we talk about the calculations in trigonometry. Now these are the very simple fundamental questions over here. This is a right angle triangle and angle A is 90-degree over here. So here the measurements, actual measurements of the sides of the triangle are given. This you must make note of. This is 12 centimeter, this is 13 centimeter, and this is 5 centimeter. We have to find the trigonometric ratios of angle B. So for angle B, this ratio will be sine B will be equal to 5 upon 13. That is AC upon BC. So 5 upon 13. Then cos of B will be equal to 12 upon 13. And tan of B will be equal to 5 upon 12. And if we take the reciprocals, cosec B will be equal to 13 by 5. Sec B will be equal to 13 by 12 and cot B will be equal to 12 by 5. So these are the different ratios over here. These are the values of the different ratios in actual measurements over here. Now, of course, all these are prime, they are co-prime over here. So, of course, we do not cancel out or reduce them further over here. Another important thing that you must know over here, now we have taken the ratios in terms of angle B. But supposing angle C is asked, ratios in terms of angle C. Now when we take this angle, then in that case sine C will become 12 upon 13. This will become the perpendicular for this angle C over here. Similarly, cos C will become 5 upon 13. Here sine B is 5 upon 13, but here cos C will become 5 upon 13. So the angle that has been defined by the question has to be taken into consideration. Then only you'll get the correct solution. So be very careful while solving as to which angle the question suggests. Now the next question over here is right angle at C, and tan A is equal to 1 by root 3. So now you will notice over here that the actual measurement is not given. Tan A is given as 1 by root 3, and tan A, this is perpendicular, this is base, and this is hypotenuse. So tan A we know is a ratio of, or tan of the angle is a ratio of perpendicular by base. So in this case over here, we cannot write that this side measures 1 unit and this side measures root 3 unit, because this is a ratio, and ratio means it is represented in the smallest fraction. The highest common factor has been removed. So we can do one thing like 1 by root 3. The perpendicular we can take the highest common factor as x, and this can become x, and this will become root 3x. This is the highest common factor. So now if I write x over here and this is root 3x over here, and now we can find AB with the help of Pythagoras theorem, that is AB square is equal to this BC square plus AC square, that is x square plus root 3x the whole square. So this becomes x square plus 3x square, that is 4x square. So AB is equal to 2x. Now of course it's an equation and we'll get here plus minus, but it's in fact not necessary to take the negative sign, because this is a triangle, and in a triangle sides are positive, so we take only the positive value 2x away. Now sin A cos B plus cos A sin B, we need to elaborate and we need to find the value of these this expression over here. Sine of angle A, sine of angle A, this angle will be x upon, this becomes 2x, this will become x upon 2x. Cos of angle B, now we need to take cos of angle B, this will again be x by 2x. Then we have cos of angle A. Cos of angle A will be equal to root 3x by 2x. Sine of angle B will also be root 3x by 2x. So this becomes, now we can eliminate all the x's and we are left with 1 by 4 plus 3 by 4, which is equal to 4 by 4, and that is equal to 1. So the final value of this expression is equal to 1. Next question is, you'll find, notice over here that all the questions are of a different variety. Of course, you need to practice similar questions so that you become thorough with it. Now here we are given 5 tan alpha is equal to 4, and we need to prove that the left hand side is equal to the right hand side over here. So first thing, from the given part, we can write down tan alpha is equal to 4 upon 5. Now tan is a ratio of P upon B, so of course H can be found out applying the Pythagoras theorem. But these type of questions can be done in a different way also, in a very very quickly they can be solved. And how we do it, instead of finding the values of sine, cos, etc., what we can do is we can take the left hand side over here, minus 3 cos alpha divided by 5 sine alpha plus 3 cos alpha. We have taken the left hand side, so it's mandatory to write LHS over here. Now the numerator and denominator both are being divided by cos alpha. So we'll get here 5 sine alpha by cos alpha minus 3 cos alpha by cos alpha, and in the denominator again we get here 5 sine alpha by cos alpha plus 3 cos alpha by cos alpha. Now, let us get back to the sine alpha value. Sine alpha is equal to P upon H. Cos alpha is equal to B upon H. So, if we take the ratio of sine by cos, sine alpha by cos alpha, what do we get? We get here P by H by B by H, that is equal to P upon B. So, this is basically equal to tan alpha. So, when we divide sine by cos, we'll get tan alpha over here. So this becomes equal to 5 tan alpha minus 3, because this will get cancelled, divided by 5 tan alpha plus 3. Now putting the values of tan alpha, we get over here 5 into 4 by 5 minus 3 divided by 5 into 4 by 5 plus 3. So 5 and 5 will get cancelled. So numerator becomes 1 and the denominator becomes 7, which is the right hand side. So this is how it has to be solved. The next question, again it's slightly different from the previous questions. We are given here angle A and angle B are acute angles such that cos A is equal to cos B. Then show that angle A is equal to angle B. We have to show that angle A is equal to angle B. So here what we do is, we take, first of all, it must be remember that you have to take two different triangles over here with one angle A in this triangle and the angle B in this triangle. It's mandatory because if we take the same triangle, then automatically cos A and cos B will become equal, the sides will become equal. So this angles will be 45 degrees. So we'll be proving it, angle A is equal to angle B, but in that case we'll be restricting ourselves only to one angle, that is 45 degrees. So we take two different triangles over here and then we do this proving, that is angle A is equal to angle B. So first of all, let us to see what is cos A. Cos A from the first triangle will be equal to AP upon AQ. AP upon AQ. Cos B from the second triangle is a ratio of BM upon BN. BM upon BN. Now they are both equal, so we can write down AP upon AQ is equal to BM upon BN. And now we can just shift the means. This is a proportion, so the means can interchange the position. We get over here AP upon BN is equal to AQ upon BN. And since they are equal over here, this proportion, they form a proportion over here. Let's equate the proportion to a constant called K. So AP can be written as K into BN, and AQ can be written as K into BN. Now, getting back to the third side over here, why are we doing this? What is the necessity? So what exactly are we doing here? We are trying to establish that we have already got two sides proportional in these two triangles. So if we take the third side also and we get the ratio of the third side also equal to K, then automatically the three sides will become proportional of both the triangles. So then the triangles will become similar, and once they are similar, the corresponding angles become equal. So that is the fundamentals that we are going to apply over here. Now, how do we take the third side? The third side is on the first triangle, PQ square, that can be written as AQ square minus AP square. And in the second triangle, the third side, MN square, can be written as BN square minus BN square. Now, if we take the ratio PQ square by MN square, then we can rewrite AQ square as equal to K into BN. So this becomes K square into BN square minus K square into BN square divided by BN square minus bm square. So this becomes k square can be taken out as common and we are left with bn square minus bm square by bn square minus bn square. So these two get cancelled and we get over here equal to k square. So PQ upon Mn will be equal to k. So the third side is also equal to k. The ratio of the third sides is also equal to k. So all these three sides become proportional. That means the conclusion is that triangle APQ is similar to triangle BNN. So now the corresponding angles, angle A and angle B. Angle A is equal to angle B. So that is how this has to be done. Now let's take another question over. Tan theta is A by B. Prove that this A sin theta minus B cos theta by A sin theta plus B cos theta is equal to A square minus B square by A square plus B square. So again we are given here tan theta. So if we take the left hand side of the numerator over here, we get here, of the left hand side of this expression over here, we get here A into sine theta minus B cos theta by A sine theta plus B cos theta. So as in the previous case, we'll divide the numerator and denominator separately by cos theta. So we get here A tan theta minus B by A tan theta plus B. Now we put the value of tan theta, that is equal to A into A by B minus B by A into A by B plus B. So we get over here A square minus B square by B divided by A square plus B square by B. So this B and B get cancelled and we are left with A square minus B square by A square plus B square, which is the right hand side. So this is how it has to be done. Now moving on, now we have trigonometric ratios of some standard angles. So these are the standard angles that you must know: 0 degree, 30 degree, 45 degree, 60 and 90. All these angles come in the first quadrant. So we take the positive values of these angles over here. Now the table over here may look very difficult to remember, but it's not difficult at all. And there is a trick also to remember, but we can remember it very easily by a number of applications. And let me first explain this trick. This is for sine theta. Only if you know the values of sine theta, you can know all the other values. The rest of the table can be just made up with the values of sine theta. How that is done? Now this is the left palm, and we start over here with naming the smallest finger as 0 degree, like in 30, 45, 60 and 90. Now the formula is square root of x divided by 2. Now what is x over here? X is the number of fingers that are left after this. For example, after 0 degree, there is no finger. So first, if I have to find sine 0, we have taken this for sine value. Sine 0 will be equal to square root of x. That means there is no finger over here. Square root of 0 by 2, that is equal to 0. Then we have sine 30 degree. Sine 30, after 30 we have one finger, so this becomes square root of 1 by 2, that is 1 by 2. Sine 45 degree. Now this is square root of 2 fingers by 2, that is root 2 by 2, that is 1 by root 2. Similarly, sine 60 degree. This will be equal to, there are 3 fingers over here, so we'll get over here root 3 by 2. And sine 90 will be root 4 by 4, that is 1. So only if you know the values of sine, the other values can easily be remembered. How? Like sine is 0, half, 1 by root 2, root 3 by 2 and 1. So cos theta is just the reversal of this. 90 value we put over here at 0 and all the remaining values in the same sequence, in the reverse sequence. Now tan is a ratio of sine by cos. So if we take the ratio of sine by cos, we'll get all the values of tan. This is not defined because 1 is being divided by 0. If you divide any number by 0, it is undefined. Similarly, cosec is the reciprocal of sine. So 1 by 0, that is again undefined, and take all the reciprocals here, you will get the values of cosec theta. Sec theta is the reciprocal of cos, so you take all the values of cos and take the reciprocals, you will get the values of sec theta. Then we have cot theta, that is again not defined over here. First one is not defined, that is We get over here tan is 0 and 1 by 0 is undefined. And all these values come accordingly. So not to worry about, only if you know this finger trick, initially remember this, later on as you go on doing a number of questions, these values will get registered in your mind. Evaluate cos 30, cos 45 minus sin 30, sin 45. So these are the type of questions that we get. So here we have to just put the values and simplify. So what are the values? Cos 30 is root 3 by 2, cos 45 is 1 by root 2, sin 30 is half and sin 45 is 1 by root 2. So if we get this becomes root 3 by 2 root 2 minus 1 by 2 root 2. Take the LCM, you get the answer as root 3 minus 1 by 2 root 2. So you can take rationalize the denominator if you wish to do. Next question is sine square 30 into cos square 45 plus this. So we just put the values and simplify. So sine square 30 is half, so this way comes half whole square. Cos square 45, this is 1 by root 2 whole square. Tan square 30 will be 4 into root 1 by root 3 whole square. Sin 90 is 1, so half into 1 the whole square. Cos 90 is 0, so 0 whole square. Plus 1 by 24. Cos 0 is 1, so 1 the whole square. Now this becomes 4 into 2, that is 1 by 8, plus 4 by 3, plus half, and 0 can be eliminated, and plus 1 by 24. Take the LCM, 24, so 8, 3, so we get away 3, then 8, this becomes 32, this becomes 12, and this becomes 1. If you add them up together, 30, 40, 44, 45, and 48. 48 by 24, so this is equal to 2. So your answer is 2. Now here we need to find the values or solve the equation. So we need to find the values of theta. So what we do in these type of questions, we can write cos theta is 1 by 2. Now when is cos theta 1 by 2? Cos theta is 1 by 2 at cos 60 degree. So theta is equal to 60 degree. Here 2 sine square theta is half. So sine square theta is 1 by 4. So sine theta will be equal to plus minus 1 by root 2, but we will not take the negative values because right now we are restricting ourselves to the first quadrant. So this will be sine 30 degree. So theta will be equal to 30 degree. 3 tan square theta minus 1. So this becomes 3 tan square theta is equal to 1. So tan theta is equal to 1 by root 3 plus minus again, but again we ignore the negative sign because we are not going to take any other quadrant. We have to restrict ourselves to the first quadrant. So this becomes tan 30 degree. So theta is equal to 30 degree. Now here we have again to solve the equation but slightly different. Sine 2 theta. So here what we do is write sine 2 theta as root 3 by 2. Now when is sine theta root 3 by 2? Sine 60 degree. So we get over here 2 theta is equal to 60 degree. So theta will be 30 degree. Here tan 5 theta is 1, that is tan 45 degree. So 5 theta is 45, that means theta is equal to 9 degree. Now here we are given cos 2 theta is equal to cos 60 cos 30 plus sin 60 into sin 30. Cos 60 is equal to half. Cos 30 is equal to root 3 by 2. Sin 60 is root 3 by 2. Sin 30 is half. So this becomes root 3 by 4 plus root 3 by 4. That is equal to 2 root 3 by 4. That is equal to root 3 by 2. So cos 2 theta is equal to root 3 by 2. That means it is equal to cos 30 degree. So 2 theta is 30 degree. So theta is equal to 15 degree. Next question is, if theta is an acute angle, sin theta is equal to cos theta, then find the value of sin square theta plus tan square theta minus 1. Now what do we do in these type of questions? Sin theta is equal to cos theta. So if we divide both the sides, because it's an equation, we can divide both the sides by cos theta, we'll get here tan theta. Tan theta is equal to 1. And when is tan theta 1? At tan 45 degree. So we get the value of theta as 45 degree. Now going back to the sine square theta plus tan square theta, this expression, we'll get here sine square 45 plus tan square 45 minus 1. Sine square 45 will be 1 by root 2 whole square plus 1 the whole square minus 1. So this becomes half plus 1 minus 1. So this is equal to half. So this way we have, when we get a condition like this, we have to start from the condition that is given. With that, we come to the end of this video. Hope you liked the explanation. This will be continued. We have a variety of questions of these chapter to be discussed over here. Oh, kindly like, subscribe, and share the channel. Thank you for watching.